today's chemical engineering breaking news. We're going to take a look at cumene. Now, what is cumene? So as we can see here, this is the basic structure of cumene, where it contains a carbon ring and a branch. I'll show you what is that later. But first, the chemical equation for cumene is C6H5 CH CH3 bracket 2. Next slide. So, how is cumene made? Cumene is made very simply by adding a benzene with propene, which results in a carbon ring and a branch. Next. So, the basic uses of cumene. You must be curious, right? So I'm going to tell you right now. It acts as a raw material for the synthesis of other organic compounds such as phenol, acetone, acetophenone, and methylstyrene. And it acts as a thinner for paints and lacquers. So, and one of the most important uses of cumene is in the production of plastics. For example, polystyrene, phenol, formaldehyde, resins, and polycarbonate.
Hello everyone, so I will explain about the process flow diagram for the cumene production. Okay, so this is the basic process flow diagram for cumene production. So as our first moderator said just now, it is made from the benzene and propylene. So cumene is the mixture of the benzene and propylene that undergo under a certain pressure and temperature. So it is from the storage tank. It will undergo the H201 is a heat exchanger, and then the catalyst, which is our third moderator will explain later on. The catalyst will help the benzene and propylene to have a mixture in the reactor tank, and then it will go to the separator. Okay, and while it's go in the under separator, so it will produce two products, which is undesired and desired product. So the desired product that we want is cumene, and then the undesired product is diisopropyl benzene. So to make it the product selectivity ratio, to make it to maximize the product selectivity ratio, so we have two distillation tower. For the first distillation tower, it is to produce benzene and the product that we want. For the second distillation tower, this is the product that we want, which is cumene and undesired product, which is the IPP. So this is the reaction that will take over in the reactor part. So propylene with the benzene will produce cumene, which is the desired product, and then propylene and cumene will produce the undesired product, which is the DIPB. So next, general operation condition. So this is the part that I explained just now at the process flow diagram.
Okay, so I'll be explaining about the type of reactor. So the type of reactor that we choose is plug flow reactor. So this is the diagram of the reactor. So the operating condition for the reactor is the temperature range is around 300 degrees C and 400 degrees C. The pressure is around 25 atm to 30 atm, and the length and diameter we assume to be 0.9 meter and 0.2 meter. So the boiler feed water will enter and produce high pressure steam, and there's a reaction occur, which is what just my second moderator said just now, which is two reaction occur. Propene and benzene become cumene, and propene and cumene become diisopropyl benzene. Okay, so why we choose plug flow reactor is because plug flow reactor is because production of cumene involve reactants in vapor form and catalyst particles. So we assume that reactor to be isothermal because the temperature in and out is constant throughout the process. So it is exothermic heat of reaction because it removes the vapor boiler with water to high pressure steam. Okay, next. So the type of catalyst that we use is beta zeolites. As we all know, catalyst is very important in a process because it can speed up the reaction of the process. So beta zeolites is in a pellet form. As you all know, as we can know, zeolite has many types of zeolites, but we choose beta zeolites because it can produce high production of yield, high selectivity, and it can eliminate corrosion of the zeolites and eliminate disposal problem. And the most important, it is more effective because the performance control is more efficient in zeolite membrane. Okay, so next I will pass to my sport moderator.
This is the marketing information for Cumene. According to the forecast, the global Cumene market is expected to reach 28.2 billion by 2025. From the graph, we can see the data for Cumene market of each year is keeping increasing. From this figure, we can see that the phenol is the largest application segment and accounted for over 61.4% of the total market revenue. This is the application for Cumene market. Cumene can be used to produce phenol, polycarbonate, and so on. The polycarbonate resin can be mixed with glass and metals for the automotive sector, and it can also be used to it can also be applied in security and architectural outlets.